This is Professor Belton. This is part 2 of chapter 8, section 3. Starting with the cosine and the tangent inverse, right? Or arc cosine or arc tangent, if you want to refer to it that way. So again, we're under the same problem with every trig function in that if you do the horizontal line test, every trig function will in fact fail, right? So we need to limit the domain of the trig function. So we limit the domain from 0 to pi, essentially. So that is the domain of the cosine function, which again would be the range, right, of the inverse trig function, which in this case is cosine. So if we do that, we get the graphs that are down below, this being the cosine, this being the inverse cosine or arc cosine. And then in fact, they'll pass the vertical line test and they'll actually be inverses of each other as long as we limit it to that domain of the function or the range of the inverse function. And we did a similar thing with sine to negative pi over 2 to pi over 2. That was the limit of the domain, which was the range of the inverse for the sine function. Okay, so that means the picture looks a little bit different for the cosine. So basically, same thing again. An inverse cosine gives you an angle, right? So an inverse cosine of the ratio of the sides, okay, will give you an angle. So if I do cosine to both sides, right, cosine cancels cosine inverse. So I get cosine of an angle equals negative root 3 over 2, right? So what is the angle that gives us negative root 3 over 2? Well, in fact, it's 150 degrees or 5 pi over 6. And you ask yourself, well, why is that? Well, again, you have to think that when I do inverse cosine, okay, I'm limited to 0 to pi, right? So I'm going only up here, okay? So this is the positive positive quadrant, right? This is the negative positive quadrant. So I can do negative cosines, but they have to be over in this quadrant here. So if I go all the way over to here, to this angle right here, okay, this coordinate is root 3 over 2, comma 1/2, but this is a negative because it's in the, let me make a better root 3 than that. It's in the second quadrant, right? So negative root 3 over 2, right? And that, in fact, right there, that angle there is 150 degrees. Okay? And again, you can prove it to yourself by looking at the unit circle. Let's bring that up, right? There's the cursor here. I can't see it. Oh, there we go. I just drew right through it. Oh, there it is. There's the 150 degrees there. So if I go to do that angle, get that coordinate there, right? Okay. Pause the video. Try the student problem for yourself. Okay. So for the student problem, we know that some angle equals cosine inverse of negative 1 over 2. So therefore, the cosine of some angle equals negative 1 over 2. So the question is, what is that angle, right? Well, the answer is 120 degrees. And I cannot write 120 degrees or 2 pi over 3, right? Because again, cosine inverse is restricted to the 0 to pi domain, right? So from here to here, okay? So if you want a negative pi, because this is the positive positive quadrant, that's the negative positive quadrant. So if I want a negative, it has to have been over here, right? And in fact, it ends up being this angle right here, right? There's our theta, because this angle gives me a coordinate of negative 1/2, comma, root 3 over 2. Because again, when you do these are cosine sines. C before S, correct? And that angle is 120 degrees, or 2 pi over 3 radians. Okay, let's try the next page. Okay, so tangent runs into the same problem. It does not pass the horizontal line test. Okay, so it will fail. So we're going to limit it to one cycle of the tangent. which ends up being the same domain as sine, which ends up being the range of the inverse tangent. Okay. Okay, so sine and tangent end up being the same as far as inverses and the restrictions, right? And cosine ends speed it onto itself with 0 to pi. Okay, so again, limit to one cycle. So if I do one cycle, now this will pass the vertical line test. So the inverse is in fact a um, trig function or a function. No, sorry. Okay, let's try this. So tangent of root 3. These ones are a little bit trickier because the unit circle only gives sines and cosines, but we can fix that though. So some angle gives me tangent inverse of root 3. So basically, um, tangent of some angle is going to give me root 3 over 1, right? So in fact, where is that angle? All right, so let's draw a unit circle here. Okay, so I'm between negative pi over 2 and pi over 2. I have to be in here somewhere, right? So this is the positive positive quadrant. This is the positive negative quadrant. So obviously I'm going to be in the first quadrant, and my angle is in fact going to be 60 degrees, which is going to give me the coordinate of 1/2 root 3 over 2. And you're like, well, how does that help me? Well, that's cosine and sine, correct? But I don't want that. I want tangent. Well, we know that tangent of an angle, tangent of an angle equals sine over cosine. That's what tangent is. Okay. So in this case, if I do sine, I get root 3 over 2. And if I do cosine, I get 1/2. Well, those cancel and give me root 3 over 1. So that's why I know that this is 60 degrees for that angle, or pi over 3 radians. Okay. All right, pause the video. Try the student problem for yourself. Okay, so when does the tangent inverse equal -1? Or what angle will give me tangent inverse of -1? So essentially, a tangent of one angle is going to give me -1 over 1, right? So what is that angle? Okay, well, if I think about the unit circle here, I'm between negative pi over 2 and pi over 2, right? Which means I can't go over here anywhere. I'm stuck over in the first and fourth quadrants, which is positive positive and the positive negative. So in fact, I must be in the fourth quadrant because I have a -1, right? It cannot be in the first quadrant because that's positive positive. So in fact, I end up being -45 degrees as my angle. Well, why is that? Well, the coordinate is root 2 over 2, comma, negative root 2 over 2. Right? Which is cosine sine. And we know tangent is sine over cosine, right? I probably should have put 45 degrees instead of theta in that case, but that's fine, right? So I get negative root 2 over 2 over root 2 over 2, which essentially just gives me -1 over 1, right? So I, in fact, have -45 degrees or pi over 4 radians, which is the same equivalent. All right, that is the end of part 2.